Welcome to the Project Management Prepcast, helping you prepare for the PMP exam. Here's your instructor, Cornelius Fichtner.
Hello and welcome back to the PM Prepcast, where with quality and controlled preparation you will successfully be ready to tackle the PMP exam. I'm your instructor, Cornelius Fichtner. Yes, this is the lesson on the process of control quality, and we're going to be particularly focusing on defining control quality and when and how it is performed. We'll define statistical control process terminology and their differences. Then we will discuss the inputs to the process and how they will help in identifying causes of poor processes or poor product quality, and we'll discuss the outputs with a focus on how they measure, validate and verify the deliverables. We have a lot of ground to cover here in control quality, which means we broke this lesson into two parts. Part 1 contains an overview and important terminology that you need to know about. And then in part 2, we're moving on to the inputs, tools, techniques, outputs, and we'll also do a review. But right now, of course, we're going to go all the way to the top, and we'll take a look at project quality management first. Project quality management includes the processes and activities of the performing organization that determine quality policies, objectives, and responsibilities so that the project will satisfy the needs for which it was undertaken. And to help us with that, project quality management has 3 processes. It all begins with plan quality management, the process of identifying quality requirements or standards for the project and its deliverables, and documenting how the project will demonstrate compliance with quality requirements. Then we perform quality assurance. This is the process of auditing the quality requirements and the results from quality control measurements to ensure that appropriate quality standards and operational definitions are used. And lastly, we have control quality. That's the process of monitoring and recording results of executing the quality activities to assess performance and recommend necessary changes. Once again, let's find out where in the process groups our processes fall here. We have 3 processes: plan quality management, obviously a planning process group, the name gives it away. Perform quality assurance, that goes into the executing process group, a little bit more difficult to know. And then, dare I even ask, control quality, where do you think this one falls? Yes, it's obvious. Control quality is, of course, a monitoring and controlling process. The main concept you have to understand for control quality is that this can be considered a checks and balances process, because here is where you identify the causes of inadequate process or poor process quality, and you recommend the necessary actions to eliminate these, and you validate that the deliverables fulfill the stakeholder requirements for final acceptance. To see what we actually do in the control quality process, let's do a quick review of the perform quality assurance process and what takes place there. Perform quality assurance involves executing the overall quality management and process improvement activities to ensure optimal project performance. It makes certain that both the project and the project team are following the quality policies, procedures and plans as documented in the quality management plan. In summary, it will help ensure that your processes are all in order so that you will do it right the first time. That's the acronym down there. Control quality, on the other hand, doesn't measure the processes. Instead, it measures the deliverables and compares them against the standards so you can eliminate those deliverables that have not been built to standard. Control quality is a process that is not just done once. This process is performed throughout the complete project lifecycle. As in the perform quality assurance process, where quality audits may be carried out by a QA department, things can be quite similar in control quality, where your company has maybe a QC department to verify that all deliverables meet the documented quality standards. Please remember, when we say deliverables, we not only mean those that are handed to the customer, we're also referring to those additional project management deliverables, such as a budget and schedule compliance, as well as ensuring that the lessons learned files have been updated properly and that the process of information distribution was executed according to plan. There are a few terms that we should review before we move on. These terms are actually presented in pairs, and it's useful to know the difference between them. Our first pair, of course, is prevention and inspection. So prevention is what a modern quality management system is all about. You want to keep the errors out of the process by planning accordingly. It's keeping the defects from even occurring. But even with the best prevention, some inspection will always be required, and by inspection you make sure that you catch the errors that have occurred before they reach the hands of the customer, so that faulty machinery never gets sold to the customer in the first place. Our next pair of terms is attribute sampling and variable sampling. Attribute sampling is simple. Either the result conforms to quality or it doesn't. It can also be described as binary because there are only two answers. It conforms or it does not conform. If you consider an example of a facility making prescription drugs, tolerances are defined, a batch of product is tested, and it would either pass or fail inspection. That is attribute sampling. Variables sampling, on the other hand, measures how well something conforms to quality. In other words, there is a continuous scale that measures the result and its degree to conformity. If we use the same example of a facility making prescription drugs, the batch of product would be rated to show how well it conformed to the ideal quality. And our final pair of terms are tolerances and control limits. Tolerances deal with the limits your project has set for project acceptance. It is a specific range, a specified range for acceptable results. Control limits, on the other hand, is a concept that is a bit more complex. They identify the boundaries of common variation in a process or process performance that is statistically stable. Typically, control limits are set at 3 standard deviations above and below the mean, and as long as your results fall within those limits, your process is considered to be in control and acceptable. If you're scratching your head over these two terms, consider them in this way. Tolerances focus on whether the product is acceptable, while control limits focus on whether the process itself is acceptable. Let's expound a bit on the causes for the variations in control limits. We all know it's virtually impossible to have a process that is always 100% and producing perfect output. For whatever reason, errors can result. There are, however, always normal process variations. For instance, if you produce 1 million screws, there might be slight variations contained within each of them. This is referred to as a common cause. And then there are special causes. In the case of our screws, there could be impurities in the metals or materials that we're using, which could lead to a batch of screws being unfit for use. And this is then known as an unusual event. A bit earlier, we defined control limits. Another important concept with regards to statistical boundaries for meeting customer requirements are specification limits. And the PMBOK guide defines specification limits as the area on either side of the center line or mean of data plotted on a control chart that meets the customer requirements for a product or service. This area may be greater than or less than the area defined in the control limits. let's go a bit deeper in our explanation of the control limits. And to do this, let's take this graphical example here, and we'll still use our screw manufacturing there as the basis. So for the control limits, we look at the process and we say, if we produce screws with a weight in between a lower control limit of 3.1 grams and an upper control limit of 3.9 grams, then the process is under control because it produces an output that is in between our limits, the LCL and the UCL, they're the lower control limit and the upper control limit. The specification limits, on the other hand, they focus on the customer requirements, and the customer tells us that the screws can be anywhere from 3.0 up to 4.06 grams, and they are still usable. So here we have the lower specification limits in yellow and the upper specification limits on the other side in yellow. And when we measure and we find that our screws are in between the control limits there of 3 sigma, then we do not have to adjust anything. Now let's assume that our customer comes back to us and starts tightening their specification limits. So instead of having the yellow specification limits on the outside of the control limits, they're suddenly on the inside. But as you can see at the bottom there, our process still has a normal variation of producing screws that are somewhere between 3.1 and 3.9 grams. But the customer told us, hey, I can only accept them if they're somewhere between 3.3 and 3.7 grams. That means we now have a problem because some screws will fall in between there in that red area that I just brought up. And of course the customer won't accept those anymore. We have to scratch our heads here because we have 2 options. We can fix our process and ensure that the control limits match the specification limits, or we can inspect every single screw that we produce before we send it to the customer. So if you had to choose, which one of these options would you take? Of course, the answer is that we want to change our process. And if that was your answer, then you have correctly understood the primary principle that quality is built into the product and not inspected into the product. I'd like to make one final note regarding the specification limits and the control limits. Specification limits define what the process results should be doing, and control limits show what the process is actually doing. It's important to realize that specification limits are in no way related or connected to control limits. And with that, we have come to the end of part 1 of this lesson. So it's time for Justine to say,
See you on the flip side.
And I say, until next time.